In this VAMAS file, there are a set of spectra that were measured from the same sample using different pass energies. And as a consequence, the count rate for each individual spectrum is different, and therefore when we overlay these data in the active tile, then the difference in the count rates means that we can't see clearly the relationship in terms of position or shape for these spectra. Because these data have different count rates, we need to normalize the display, and this can be done using an option on the y-axis property page of the display parameters dialog window. And the first mode of normalization that I'll illustrate is normalize display at a point. There is a second parameter that is associated with normalize display at a point, and this is an AV width, and uses the same logic as the AV width in a region. That is to say that when we specify a number here, then a number of data points will use to average to calculate an intensity which will be used for the normalization of spectra. The same normalization options are available via this toolbar button, and when I press this once, I end up with a normalization point at which the set of spectra are all normalized, and this means that for a given point, all the data points for each spectrum at this point all pass through this value of intensity. It's easier to explain how this normalization occurs if I use points rather than lines to display the data. I'll also change the color so it's easier to see, and there we have a set of points, and the points are colored for each one of these spectra, but at this one point here all of these points overlay, so we just see a single point. Now if I offset these data, you can now see that for each spectrum there's a point at this position, and when I remove the offset, then we only see the one point. It may be better to do the normalization at some other point in the data rather than at this point in the background, and to move the point to a different position, you hold the shift key down and then click with the mouse over a given point, and then the normalization point changes. So if I expand this, we can see that we have the data normalized at this point, but it may not be the most appropriate point for the data that we're looking at here. For example, we may want to normalize at the peak maximum. It's at this point that we might like to use the average width option on the y-axis property page. It's currently set to 0, which means that a single point will be used to tie these data together. If instead I specify an interval that is defined in terms of an average width of 20, so that will be 41 data points that will be used to calculate an average value, and it'll calculate an average value for each and every spectrum, and then the average value will be aligned. So we can see this better if I enable an option that says mark region AV width, but the AV width for the y-axis is also enabled by this display option. So when I press apply, we now see vertical markers, and these vertical markers indicate the range for each spectrum over which this average is being calculated. So I'll press OK, and we can see here a horizontal line, and this horizontal line is the value calculated from each spectrum that will be used to scale these spectra. The use of these extra data points are important for understanding this particular set of data. If we look at the key that goes along with these data, we can see that the pass energy 10 spectrum is now the highest, in the sense that it has a peak that is higher up in intensity than these pass energy 20 and 40 and so on. If it were the other way around, that would be surprising, because we would expect better energy resolution from pass energy 10 than any of these other pass energies. So by using enough data and removing the noise within these data, it is much easier to see the true relationship between these peaks. The other mode for normalization is to normalize the intensity range, and this is indicated by these two vertical lines here, that the data are now being aligned in such a way that when the data are plotted, then they all are spanned over the same interval within the display tile. So we can see the maximum all align and the minimum all align. So this is a different perspective. It gives us an idea of how well these peaks might align in terms of the peak maximum, but there may be other facets of the data that we lose as a consequence of this type of normalization. As we saw before, that once we use a normalization over a range, you do see that the parse energy 150 is producing a broad peak. This is because the signal has been spread out. Without normalization, we can see that the parse energy 150 peak is in fact the most intense peak.